Welcome back to our video module on statics. We've been covering supports, reaction supports. We did it in 2 dimensions, and today we're going to do it in 3 dimensions. We're going to line out all sorts of different types of supports that are available and that you'll see, and how we can understand what they're doing. So today we're going to be exploring my Tacoma, my Toyota Tacoma. Here we're looking at the back, the lift gate on it, and we're going to be able to find all sorts of reaction points or types of reaction points on the Tacoma. The first one I'd like to quickly take a look at is this shock absorber right here. I use it to hold up the lift gate. The other one actually broke the other day, but you know, this one holds up the lift gate. We're going to play it and just watch it go back and forth. It's closing. Now, one of the things you'll notice here is this is kind of like a pinned end. It's like pinned in 3 dimensions. It's a ball and socket joint. And that just means that there's no torque generated here. What we have is this shock only resists force along its axis. It doesn't resist force this way. There's no rotational force that it resists. It only resists force in this direction, which means basically the way we say it is we say it has a reaction, and we know its direction, and we can figure out its quantity, of course. So there it is, going up and down, and as we go up and down, we're simply let's watch that again. Here it is. It's pushing in, pushing out. So it begs the question, in that case, we have one force, we know its direction, but interestingly, you might think that because it's preventing something from rotating, that it itself is applying some sort of torque, but it's not. It's only applying a force. These are some of the at first glance it looks one thing, but later on as you look at it more carefully, you realize that something else is happening. Let's take a look at this carefully. First things first, in 3 dimensions, a force acting in one direction or in a direction that we know. Let's take a look at some examples. Here we are, again on my truck. Cable. Once again, we have the lift gate is rotating, but what's stopping it is not anything causing rotation. It's just this cable. And the only force it's applying is along the direction of travel. You can see it snap. The next item looks totally different, but it's the exact same concept. Here we have a wheel rolling. The only force is the force supporting it. We saw this in our last video. Here, let's try that again. There you go. The only force is going straight up. Nothing stopping it. One force, known action. Let's find another one. All right, here's a couple that I've drawn out. The first one on the left, this is in 3 dimensions, a frictionless surface. So you can imagine that in 3 dimensions as well as 2, there is no, the only force that's happening is force straight up. In addition, you have here a ball. So you can imagine some sort of rod that has a ball recessed into it, and the ball rotates freely, so it can travel horizontally. But the one thing it does is it has a reaction force straight up. Let's take a look at the second one. I'm sorry, the second type of reaction point. Here we go. The second type of reaction point, we have a vertical force, and we have a force going in the z direction coming towards us. Now it just means it could be going in the horizontal direction too. The point is that you have 2 forces or a force acting in a known direction. Now we saw the wheel earlier that was rolling freely. If we had just put on the brakes, that would be a force that would be in an unknown direction, because now you have a horizontal force as well as a vertical one. Another way to look at it is, let's take a look at this roller, okay? The roller is pushing up. In addition, if you were to push right into us, say right like in this direction, like into us, the roller has traction. So it's going to try and prevent going sideways. This is one way that looking at things in 3D is a little different than in 2D, because a roller here, it doesn't want to go sideways. Now, as a caveat, and you need to keep this in mind going forward, we are not going to, the way we generally do this is we look at the way a part is generally used or is designed to be used. In other words, if you're careful, you'll take a look at this roller and you'll notice, well, Brad, the other thing that it does is it prevents rotation in this direction. Okay, yeah, you're right. But a wheel is not designed to do that. So when we go through all of these steps, some of them in practice may have a limit, may limit certain type, or may have a certain type of reaction, may limit the overall way that something is moving, but it's not designed that way. That's not its primary function. So we simply say that that's something that it does not offer a reaction. So in this case, we are saying that a roller is two forces. The next object, let's take a look at what happens if we prevent, or if there's a torque reaction. Sorry, let's not do that yet. Let's first take a look at just a rough surface, something that is reacting in 3 dimensions. This is basically what we're looking at. We have a force going up, a force going down, and a force going across, a force coming towards us. And let's go ahead and insert the perfect example of that, simply a tire. So in this case, a tire, we are going to restrict the force going vertical. Let's take this. There's going to be a reaction going this way. There's going to be a reaction going this way. And if you insist on pushing it sideways, there will also be a reaction this way. It's just sitting there. Anything on a rough surface. So that rough surface would look, well, it looked like the other one right up there. Let's see if we can provide that. There you go. It's going to look at the same as the frictionless surface, but you'd say rough surface. So there's another example. Let's add some torques now to this. Let's bring up our axes, take a look at what that would mean. Here we go. We're going to have reaction force vertically towards us, horizontally, and we're also going to have a reaction force in this direction. Now, what would that look like? What would that look like? Here we have an example of one, a U-joint. This is my transmission. This is the shaft that goes to my rear wheels. And you'll notice something funky going on here. We'll bring up another video that looks at it more carefully. But what it allows me to do is this is going to rotate, support the shaft. The shaft will rotate, but it allows the shaft to move in the vertical and horizontal directions. We're just going to take a look at it as it rotates. Right there we go. Let's try this again. So in this case, we can see that the motor is driving the shaft. That's what's happening here. That's the reaction. Let's take a look at something a little that will clarify it so we can take a look at it really in action. Here we go. Here I've pulled up a socket set that I have, and I'm rotating these so you can see what's happening. All right, so this is rotating, and that rotation is being shifted here. You'll notice that I can move this socket this way, in this direction. In other words, I can rotate the socket in the other dimensions, but I can't rotate it, like I'm going to tighten or loosen the nut without rotating this part. It's constrained. So in this case, I'd suggest look on YouTube. Find some neat videos of U-joints. Universal joints is what technically they're called. Everyone calls them U-joints though. And this is an example of forces acting in 3 directions, 1 torque being applied. The next item I want to put down here is a bearing. Now this bearing is special. So this bearing allows, of course it allows rotation. So if you're trying to it's not going to have, it's going to allow this. There's not going to be any reaction regarding the torque. In addition, the rod can slide back and forth in this bearing. So it's not going to have any force in the horizontal direction. Go ahead and put it on pause for a moment and see if you can figure out what the reactions are that it exercises on the system. All set? Last chance. Here we go. So in this situation, it restricts force, or I'm sorry, it has a reaction in this direction. It has a reaction coming towards us, and you see that here. You can imagine if you're looking at the joint that it's going to push up. It's going to push up, basically it's going to end up transmitting the force through the rod. It's going to push up this way. It can also push, quote unquote, sideways in this direction. And if you try rotating this whole, if you try rotating the whole setup, whoops, I switched my forces and the colors. It will have a reaction this way. We'll have a reaction coming towards us. But then in addition, if we want to rotate it like this, we're not going to be able to. That bearing, it's going to keep that from happening. And in like manner, if you try rotating it in this direction, it's not going to allow it. There's going to be a reaction there. So this is a case where we have two forces, two torques. Let's take a look at another one. Sorry, before we go to another one. So I tried finding this on the vehicle, and I had a bear of a time. There's plenty of bearings like this, but none of them are really that easily accessible. So let me show you what I did find. Right here I have my sun visor. Now it's certainly not a bearing, but because it's on this pin, it rotates in that direction freely. Okay, so there you have your rotation. It's not going to have any reaction rotating. In addition, I have this extender. This allows, it has no reaction pushing in this direction. In other words, it can move there. Let's take a look at what we have. So we have pushing in and out, so we have no force reaction there. And we also, let's play that again. We also are allowing rotation, so there's no reaction there. So this is a case where we have two forces and two torques. The next item is three forces and two torques. So here, the only thing that we're allowing to happen is rotation. There's reaction force here, reaction force here, reaction force here. An example of this would be a pinned hinge. So in this case, you can see what's happening. You're not going to allow force in this direction. You're not going to allow force coming towards you, and you're not going to allow force going up. In other words, there's going to be a reaction there. And in the like manner, this will not allow a rotation here, and it won't allow a rotation here, but it will allow, because of this pin, it will allow this whole thing to rotate. So in that case, there won't be any reaction there. One example of this is a door hinge. Here's a picture of our door hinge, supported in every direction. It does allow rotation. Let's take a look at a video of it. Now, okay, let's try watching that again. Here it is. So you can see it just rotating along there. We'll scroll down for our final example, which is a fully fixed support. For effect, I've put in the same antenna because it works in 3 dimensions just as well. But here we can see that we are offering reactions vertically, horizontally, and towards us. Finally, let me show you what I've developed for reference. This is a Word document, but I'll have the PDF version of this available for you online, so you can take a look at examples of different reactions and how they work as you hit your problems. We'll probably get to explore some of these on our next problem. I hope that helps you out, and I look forward to seeing you then. I should make a quick note that there's tons of these out there. So just keep your eye on. These are some of the most common ones, and we'll learn about more later on. Thank you.